Hello everyone, welcome back after Thanksgiving break. In this lesson we're going to be talking about, I don't know if we'll make it to the ice cream today, but we're at least going to be talking about correlation and how, in data, how we can interpret some scatter plots of data. Like I said, we're going to start off with correlation and causation of data. And let's just see how that would look in the star test. What you're going to be expected to do is you're going to have to be able to calculate using a calculator, using technology, a correlation coefficient. And that's what today's lesson is going to be about. What the correlation coefficient is going to measure is the strength of the linear association. So that means out of this question here, and all of these numbers, it says heights and lengths. So we would assume that the height is the x and the length is the y. If you made a big table and you put all these numbers in your table, today we're going to be using a calculator, and that calculator is going to tell us the strength of the correlation, and it's going to tell us whether, in general, the data is going negatively or if the data is going positively. Well, we'll talk about it in a few slides, but it's really not that bad at all. All right, let's think back to 7th grade. You should have learned about correlation even last year. A little bit. So like in this scatter plot here, how would you say that the dots are correlating? What is the relationship of these dots, of these points, of this data? Well, at the very basics, what you should have learned last year is that this is a negative trend. Based off of what you learned in 7th grade, you would be able to tell that this is a positive trend, but in case you can't tell because of what you learned in 7th grade, you can just look, and if you put a line through the data, you try to get half of the points above the line, half the points below your line. You just try to make your line go through the middle of all of your dots. It doesn't connect all your dots, but if you can just put a line going through them all, that line is showing you the average of what that trend is doing. And this line is saying that we have a positive correlation. If you look at your data, and you can see that, yeah, these dots are all trending downwards, you would prove that by using a line through the middle to see that, yes, that line really is going negatively. We can see that these dots are going from left to right. They are going upwards, so that is a positive correlation. What about this one? Can you put a line going up? Could you go straight? Could you go down? None of them really match the data, so this one would be called no correlation. What about here? It's going downwards, so negative correlation. On top of just being positive or negative or no correlation, you can also say, just add one word to say whether the correlation is strong, weak, or like very weak or very strong. You know that a correlation is strong or weak if if all the numbers, if you could put a line going through it, if you could put a line going through it, and all of the dots are relatively close to that line, like these ones, it's not very far off from the line. So that you would say that that's a strong one. And if you draw the line going through it, but the dots are a bit farther apart. Look at that. That one's really far away, really far away, really far away. Yes, there are some that are close, but there are a few that are really far away. Then you would say that the correlation is going to be weak. What that means is that while yes, you can draw a line through the data, that line isn't very accurate. In the strong one, that line, it's really close to all the dots, so you would say that it is very accurate and it has a strong linear correlation. The weaker your trend is, like this one, like you could put a line, but that line really doesn't represent those dots at all. It's not a very strong linear association at all. Because we need to be able to determine the strength or the weakness of a correlation, there's actually a way that we can put these in the calculator to find the line of best fit.